Hello and welcome. This is very useful pandas functions for everyday data analysis tutorial. And this tutorial, you are going to learn about pandas str accessor. Pandas is a highly efficient library on textual data as well. The functions and methods under the str accessor provide flexible ways to filter rows based on strings. In this tutorial, you are going to answer two basic questions. The first question is, let's assume your manager needs a list of employee names that the name starts with the letter J or ends with letter N. And the second question is, your manager might be asking you to bring all the employee names that contains the letter M and starts with the letter J. As a data scientist, how do you filter the rows from the data frame? To answer these questions, we are going to use the most commonly used str accessors. These functions are starts with, ends with, and contains. We are going to pass the strings into these functions. Okay. This is your data frame, the data frame containing name, birth date, and country. You are asked to filter the rows, the name containing, the name starts with the letter J or ends with letter N. So manually filtering is not advisable because you may have large volumes of data. So it is difficult to filter the rows which starts with the letter J or ends with letter N. So we are going to apply some functions to filter rows from the data frame. Okay, so this starts with is very useful. We pass a string into this function. So it's going to evaluate the name column, the values of the name column, and it's if it is satisfies this condition, it's going to retrieve the rows from that data frame. So we just use data frame name dot column name dot str dot starts with this function takes the string or character. So it's going to filter the rows if the name starts with J and or ends with N. So these two functions are very useful to filter rows from data frame. So so the result of this logic is either true or false. If the logic is true, it's going to filter the rows from the data frame and combined by OR operator and evaluates the second operator, logic. The second logic is the name ends with the letter N. So this result is that the rows that the name starts with J and ends with N. So J starts from J, Joss, for example, Cathy Martin, ends with N, Corey Morgan, ends with N, Janet starts with J later. So this is one way to filter the rows from your data frame. The second question is about contains the character. So the contains function under the str accessor returns the values that contain a given set of characters. The name at least containing one character that's specified into that function going to be retrieved or filtered. So we are going to apply these functions contains data frame dot name dot str dot contains, and we pass the character here as a string. The character, if the name contains M, it's going to be filtered across the row. We combine the two logic using OR operator, and the second logic is about the name starts with J. So it's going to filter either contains M or starts with J later. So this is what the result is. So for example, the first row name contains M character, The second starts with J, okay? The third contains M character, and so on. So all the rows going to be filtered, which satisfies these conditions. So those are very useful Pandas str accessor functions for filtering rows based on the strings we provide to the function. What is pivots? A pivot is used to reshape a given data frame organized by given index or column values. If you wanted to reshape your data frame based on the index or column values, so this pivot function is very useful to solve your problem. This is a general syntax to use pivots in pandas. The pandas does pivots, and we pass the data frame, and we also pass index. Is by default it is none, but if it is none, it uses existing index, but we can pass the index column or the column that's going to organize your data frame as index and columns, and these columns is to use to make the new frames columns, and the values that going to be assigned to the new reshaped columns is this is also a column. So this is the general syntax and how we can do this. This is an example. We have 4 columns and 4 rows. Item column, customer type, gold, bronze, gold, silver, and price in USD and in euro. Such a table, it is not easy to see how the USD price varies over different customer types. So how can you compare the prices for each customer type, gold, bronze, gold, silver? So to easily understand and to easily compare the prices of each customer type, you can just reshape your data frame based on the item and the customer type, and we just convert the item into indexes and the customer type, gold, bronze, and silver, into columns, and the value is going to be the USD for each customer type. So that going to easy to compare the customers for each item. So this is the way we pass the data frame dot pivot. Index is the item, going to be the item index 0 and 1, and the columns that going to be is the customer type columns, going to be the columns for the new data frame, and the values for the new data frame columns going to be the USD values. Okay, so when you transform this, yeah, you can see simply the customer item 0, item 1, and the customer type values going to be transformed into columns, bronze, gold, silver, and the values for each customer types are the prices in USD. Now you can simply understand the prices in USD for each customer type of each item across the row. So this is the way how you can transform or reshape your data frame. But pivot function does not support data aggregation. Multiple values will result in a multi-index in the columns. So it doesn't support data aggregation as well as multi-index columns in pivot. So what we can do is pivot underscore table. So this pivot underscore table method comes to solve this problem. It works like pivot, but it aggregates the values from rows with duplicate entries for the specified columns. Duplicate entries. So in other words, in the previous example, we could have used the mean, the median, or another aggregation function to compute a single value from the conflicting interests. So in this case, we are going to use a mean or median values for the prices in USD to easily compare for each item in each customer type. So this going to be solved using pivot underscore table instead of pivot function. So in this function, we pass the index is item, and the column is going to be the customer type, C type, and the values going to be the USD in each customer type for each item across the row. And the aggregation function or ag function going to be the mean of the values for each row, the mean of each row. So it's going to be, and reset the index, it simply understand. So this is the way how we can solve such kind of problems. So if you want to aggregate, because pivots cannot support aggregation function. And one more example is here I have a data frame, indicator column, country column, year values for each country, for each year, for each indicator. And I would like to transpose the table so that the values in the indicator columns are the new columns. But here we are going to use multi-index columns because we have two columns that are going to be duplicated, and we are going to use multi-index as well. So the value is going to be the values for each column, and the new data frame column is going to be value. The index, multi-index, that's supporting multi-index because it's going to be aggregates based on the country and the year because they are duplicated. And the columns are indicator. The indicator 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we will have 5 new columns. So and we will have 2 rows because we will have one country only, Ethiopia, and 2021 and 2022 in year. So we will have 2 rows and around 7 or so columns. So here the indicator columns, country, Ethiopia, we will have 2 rows, 21, 22, different years. And 1, 2, 3, 4, 5, the indicator columns values going to be transformed or transposed into columns, and the values column are going to be the values for each new columns. So this is the way how you can you can transpose, reshape your data frame either using pivot or pivot table. So the 2 functions are very important to reshape or transpose your data to especially to compare, to aggregate the columns, rows in based on index and column and values. In a sense, pivot table is a generalization of pivots which allow you to aggregate multiple values with the same destination in pivoted table. I'm going to talk about where function in pandas. The pandas where method is used to check a data frame for one or more condition and return the result accordingly. Let's assume you have a data frame, a large data frame, and you want to check the data based on the condition. So this where method is very useful to check your data frame, and it's going to return the result accordingly the condition. By default, the rows not satisfying the condition are filled with non-value. If if the condition, this is actually the general syntax of the where method. The where method takes some parameters. but the most important parameters in this case is condition. So the condition going to be evaluated here. If this condition is true, it's going to keep the original values of the data frame. Otherwise, it's replaced by other value or replaced by none, not a number value across the row, which means that rows not satisfying the condition. In this, to just understand, let's try to see an example. Filter the data where age is greater than 30. For example, let's assume you have a data which contains age distribution, and you want to filter or check the data which age is greater than 30. So this is your data frame, and this is the condition. The where function takes the condition. Any you can actually apply one more conditions. In this case, I have just applied one condition. So this is if statement edo. So you can apply any condition in this function. If the data, the age column, the values of age column greater than 30, it's going to be keep that value. For example, 50 is greater than 30, that is true. And for example, at row 3, the value is not greater than 30. So it's going to be replaced by none, not keeping this value as it is, because the condition becomes false. So it is not satisfying the condition. So it's going to be replaced by other value, or it's going to be non-value across the row, or the row going to be none. And 40 is greater than 30. That's okay. It keeps this as it is, and 20 is also not greater than 30. So it's going to be replaced by none across the row. This is the result you get. So you have only 3 rows that the age is greater than 30. At row 0, at row 1, and fourth row. So other conditions are not satisfying. That is false. So it's going to be replaced by non-value, or you can also replace by any other values if the condition is not satisfying. So the where function can be used to replace certain values in a Pandas data frame. For every value in a Pandas data frame where condition is true. Otherwise, it's replaced by non-value or other value. This is Pandas data frame mask versus where method. Pandas, the mask method is an application of if then edo. This is the general syntax of Pandas mask method. Data frame.mask and passes the parameters. The condition is going to be evaluated here if for each element in the calling data frame, if the condition is false, the element is used, which means the original values in the data frame going to be kept. Otherwise, the condition is true. The data or the values in the calling data frame going to be replaced by other or non-value by default. So let's try to see an example how this going to be performed. But let's try to see where method in Pandas. The where method is used to check a data frame for one or more conditions and return the resulting accordingly. The same is true for mask. But the difference is the condition in the where method going to be evaluated either true or false. But when the condition is true, the original value in the data frame going to be kept. But in mask, the condition is true, the original value in the data frame going to be replaced by none or other. That is, the two functions are opposite, but they use the same parameters, but the functions are, or the purpose of the two functions in Pandas are opposite. So let's try to see an example. Here we have a data frame which contains two columns, age and qualified. The age is a random age, 30, 10, 20, 40, 30, 40, 50, and so on. This is the original data frame. If we want to evaluate the condition if the age is greater than 30, let's try to do the mask. If the age is greater than 30, if that age in each value in the data frame, it's going to evaluate each value in the data frame. For example, just evaluate the first row at age column. Age is greater than 30. That is true. So it's going to be replaced by none, not keeping this value in the data frame, the original data frame. It's going to be replaced because it is mask. And the second row is also greater than 30. It's going to be replaced by none or other value. Across the row, actually, it's just replaces the row values across in the data frame, not exactly that specific value. It's replaced by none across the row if that condition becomes true. The same is true for all rows in the data frame. So this is the mask. What about the where function? We use the same condition and we will see different results. Where the condition is true, it's going to keep the original value across the row in the data frame, not replaced by other, because the condition is true in the where. But in mask, it's going to be replaced by none or other value across the row, because that across the row is not satisfied in the mask, but in the where it's satisfied when the condition is true. So let's try to, for example, at row 3 in the mask is the original value is already kept because it is false. When you see here, it's going to replace by none value across the row because the condition becomes false in the where. So this is the two most important functions in Pandas, very, very useful for data analysis. If you want to filter data based on the conditions or so you can drop none values from this, drop NA. Just you can filter the values. Simply you can drop none, not a number. So this is the way how you can filter data from your data frame, because you may have large data in the data frame. So you wanted to filter some specific data from that data frame, and you can use either mask or where condition, function based on the requirements that you want to filter from your data. Here, let's talk about ilog and log. The data frame dot ilog function takes as a parameter the rows and column indices and gives you the subset of the data frame accordingly. First of all, let's generate a dummy data. If you are new to this, you can simply generate a dummy data which contains name, birth date, country, etc. using Packer Python library, and then we can just generate a data frame. The data frame contains 10 number of rows and 3 columns, name, birth date, and country. So from this, I am going to take the first 4 rows of data and index first to index third columns. Just if you wanted to just take the first 5 rows or 4 rows from this data, and from columns, you can just take, for example, first column, first index column, and up to third index column, which means first and second columns. So this ilog is very useful to just slice the data from the data frame, and it takes the rows, index, and the columns. So let's try to see. just you can create a new data frame, which is sliced from the already existing data or all the data frame. We use illoc. The illoc, the first is the row, slicing the first 4 rows. The index starts from 0 up to 4. 0, 1, 2, 3, 1, 2, 3, 4. So it is up to 4, not including the last index 4. And the column indexing is just taking, for example, first column, that is birth date, and up to the third column, because when you are slicing, the last index will not be included in the slicing. So this illoc takes the first 4 rows and the first and second column from the data frame. And when you run this, you can get the first 4 rows, first row, second row, third row, fourth row. And birth date and country is sliced. So this illoc is very useful to take any data based on the row index and column index. Another useful function of Pandas is log. This log does almost the similar operation as illoc function does, but here you can specify exactly which row index you want and also the name of the columns you want in your subset. And instead of passing the index, you just pass a specific or exactly which row index you want to slice or just extract, and also specify the name of the columns. This is different from illoc. illoc just take the rows index and the column index, but here you are going to specify at which row index you want to take and at what column names you want to take from that data frame. In this case, it's going to extract index, row index at 2, at 3, and 4, and from the column just extract name and birth date. So we are going to just get index 2, third and fourth index, and from column we get this. So the two very, very useful functions are important for your data analysis. You use those functions for daily data analysis purposes. So learn a lot about data Pandas functions, because very, very useful. illoc and log are very useful, especially for data manipulation, data aggregation, and so on. So this is today's top tip tutorials. So next time we will learn another topic. So subscribe, like, share my YouTube channel, and stay with us. Thanks for watching today.